Hello friends, and welcome to the session on permutation and combination. Permutation and combination seems to be a very difficult topic to most of the students, but if we approach it in a right way, it is not at all difficult. It is actually derived from our basic counting thing, right? So we count the things, and then if the number of objects becomes too high, it's difficult to keep the track of those countings. So there are certain set methods so that we can keep a track and find the number of combinations or permutations or whatever the case is, right? So let's see how to approach this topic in a very systematic way so that you understand and you appreciate the kind of problems which appear in this topic. Agenda would be very simple. First, we would be using something called a factorial here, right? I'm sure most of you know what is factorial, but still we would see what is a factorial. Then we'll do basic counting principles, then permutation, then combinations, and then few test cases. Perhaps we would do 2 to 3 sessions on the concepts on these videos. So this would be the session number 1. Now let's go to the definitions of factorial, right? So factorial is denoted by, factorial is firstly always found for a whole number, right? So it can be found for 0, 1, 2 up till infinity. There is no factorial for a negative number, right? So it has to be for n has to be a whole number. It is denoted by an exclamation mark. So n factorial is equal to n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 up till 1, right? So let's take an example. 5 factorial would be, it would be n, which is 5 into 4 into 3 into 2 into 1, which is equal to 120, right? Similarly, 4 factorial is equal to 24. So I advise you to keep in mind the factorials till 8 or 9 factorial or even 10 factorial, right? So 1 factorial is equal to 1. This is obvious, right? But by definition 0 factorial is equal to 0, right? So this you have to remember, that 0 factorial is defined as 1. Sorry, I just put a 0 there. It has to be 1. So 0 factorial is equal to 1. This is by definition. So you have to keep this in mind, right? So these are the basic infrastructure which we are requiring for this chapter. You don't need anything more. We would build in the definitions of what you have learned, which is NPR and NCR and all this stuff, right? But that we would do in maybe the next session. Now let's come to basic principle of counting, right? Before introducing any basic principle of counting, let me take an example which says you have to go from town A to town B. There are 5 buses and 4 trains from A to B. In how many ways can you travel, right? So this is simple, right? Now you have to travel from A to B. You can choose either bus or train, right? So either bus or train. You cannot choose both to travel, right? So it has to be either bus or train. So keep in mind that you have to choose either of them. So there is or in between, right? Bus can be chosen in how many ways? 4 ways. And train can be chosen in how many ways? So bus can be chosen in 5 ways and train can be chosen in 4 ways. So the total ways in which you can travel would be how much? Either you travel by bus, you can take 5 buses, or you can take 4 buses, which is equal to 9, right? So this is something, this is an example of basic principle of addition, which says that if a thing can be done in n ways or m ways, right? So n ways is 5 buses and n ways is 4 trains, then the possibilities or then the number of ways in which the thing can be done, right, is m plus n, right? So if this happens only if you have to choose one of the 2 things, right? Let's take another example. There are 2 boys and 3 girls in a class. In how many ways can you choose a topper, right? Now we have to choose a topper, and topper can be only one, right? So let's say there are 2 boys B1 and B2. There are 3 girls G1, G2 and G3, right? So topper can be any one of these. So out of boys, how many ways can be there so that we have topper? Either B1 or B2 is topper, right? So there are two ways. From girls, either G1, G2, G3 is topper, right? Now since the topper is 1, out of these 5 there can be only one topper, which means 2 plus 3 is equal to 5. So there can be 5 ways of choosing a topper, right? This is again simple basic counting which we are doing, right? So you have 5 people. How many ways can you choose a topper? Either B1 can be topper, B2 can be topper, or G1, G2, G3 can be topper. So there are 5 ways. Now if it says, so this now introduces another principle, which is basic principle of multiplication, right? So now there are 2 boys and 3 girls in a class again. In how many ways can you choose a girl's topper and a boy's topper? So now you have to choose a girl's topper and a boy's topper, right? Now let's see what can we do. So let's make a table here, right? Let me merge this. So for example, we choose boy's topper first, right? Let B1 is the boy's topper, right? Then girl's topper can be G1, G2 and G3, right? These can be the girl's topper, right? Similarly, let's merge these even, right? So there are 3 ways. If B1 is topper, then girl's topper can be G1, G2, G3, right? So the top list of the toppers would be B1, G1, B2, G2, B1, G2 and B1, G3, right? These can be the cases in which girls and boys topper can be chosen, or it could be B2, G1, B2, G2 and finally B2, G3, right? So these are the ways in which the toppers can be chosen, which means we are choosing boys topper in 2 ways, and after choosing the boys topper we are selecting the girls topper, right? So what we are doing is, these two are independent events, right? Choosing boys toppers and girls topper are independent event, but they are occurring one after the another, right? What we are doing is, we are firstly choosing boys topper and then choosing a girls topper, right? So since both of them has to be performed, we are multiplying it, right? So this becomes 6, right? And you can see that only there can be 6 combinations possible, right? Right? So this is how we do the basic principle of multiplication. You can also argue that we could have chosen the girls topper first and then we could have chosen the boys topper, right? Yes, we can definitely have done that. So it could have been G1 B1, G1 B2, right? G2 B1, G2 B2 and finally G3 B1 and G3 B2. Now you see that G1 B1 and B1 G1 is same combination, right? It's not different, right? So the number here is again 6, right? Now and B1 G1 and G1 B1 is same, and it does not make any difference that whether we write it as B1 G1 or G1 B1, right? So this means both of them are same, but there can be a case where B1 G1 and G1 B1 are different, right? Here it is what we are doing and we call is selection, right? So selection means we are selecting one then another, right? Here what we are doing is arrangements, right? So this is the basic difference. If we combine both these two, we would get 12 ways, right? So these are the arrangements, right? So if the question says that let's go to next question and you would be clear. there are two boys and 3 girls in a class. In how many ways can you choose top 2 students, right? So top 2 students we have to select. Their number of students are 5, right? So first student can be chosen in how many ways? He can be chosen in 5 ways. Let's say the first student is A, B, C, D and E, right? So first student can be either A, right, and the second student would be B, or second student, so there can be a combination A, B. First student can, if is A, second C, first A, second D, first A, second E, right? So these are the 4 combinations if A is chosen. Now if B is chosen, it can be A, B, C, right? It can be B, A as well, right? Because we have to choose top 2 students. So B is first, A is second, right? It is different from AB. If you can see that, it is different from AB. And then it would be BC, then BD, and finally BE. Now if we take C, it can be CA, CB, CD and CE, and finally if we take D, it would be DA, DB, DC and DE, right? And finally if we take E, it would be EA, EB, EC and ED, right? So they become how many? These becomes 20 different things, right? So what we are doing here is we are arranging them in order, right? Here A is first and B is second. Here A is first and C is second, whereas here B is first and A is second. So AB is different from BA, right? That's what is the difference, which is different from the previous example where B1 G1 is equal to G1 B1, right? So this is a typical example of arrangement. Arrangement means order does matter, right? Here order is mattering to us because A can be first or A can be second, right? So order matters to us, right? So how can we do it without writing it? We can now choose the first position in 5 ways. First position can be A, B, C, D, E, right? So here also, for these 4 we are choosing A as topper. For these 4 we are choosing B as topper. For these 4 we are choosing C as topper. For these 4 D, and for last 4 E, right? And if for every one selection there are 4 other selections, right? If we choose A as topper, then the second can be B, C, D, E, right? So this means the total are 20, right? So this is the basic principle of multiplication, gives us the number of arrangements, right? Which means whenever you apply basic principle of multiplication, you would always get AB and BA as separate cases, right? They would be separate cases and not the same cases. Now let's go to the previous example, right? In how many ways can we choose the girls topper and boys topper? You would say that we have applied basic principle of multiplication here, right? Which is right, we have applied basic principle of multiplication, but what we are doing is we have fixed one combination. We have said that we would choose boys first and then girls first, right? So boys can be chosen in 2 ways and girls can be chosen in 3 ways, which is 6 ways. The other, if we want the number of arrangements, then there could be an arrangement where we choose girls first and then boys, which means another 6 ways, and these 6 plus 6 would become 12 ways, which is B1 G1 is different from G1 B1, right? So that's how we come to the total number of arrangements if we want to find arrangements, right? I think I have confused you fair bit. Let's go to more examples and see if your confusions is solved, right? So now there are 2 words which are selection and arrangements, right? Now in this, there are 2 boys and 3 girls in a class. In how many ways can you choose 2 students to send for a quiz, right? Now if you have to send them for a quiz, then AB and BA is just one team, right? They does not make, they are not 2 separate teams, right? So which means these 2 are same, right? AB and BA are same. Similarly AC and CA are same, right? So we have 2 groups of same thing, right? So which means we have to just divide this by 2 to get the actual number of teams which can be formed, right? So there can be 10 teams which can be formed, right? So this is the number of teams which can be formed, right? And this is what we called as selections, and we denote it by NCR, right? So there are 5 people and we have to select 2 out of them, and it is denoted by NCR, and it is given by n factorial divided by r factorial, and in the division, in the denominator, there are 2 factors, r factorial into n minus r factorial. So these are the 2 factors which are there in denominator, right? So this is what we have done. What we have done is, it is 5 factorial divided by, so it's, we have to choose 2 factorial multiplied by 3 factorial. So 2 factorial and 3 factorial, which can be written as 5 into 4 into 3 factorial divided by 2 factorial into 3 factorial, right? 3 factorial would get cancelled, and we would be left with 5 into 4 divided by 2 factorial is 2, which is equal to 10, right? So this is how we solve these kind of questions when we are to do only selections, right? Here we are not bothered about whether the team is called AB or BA, but when we were doing the toppers, we are worried about the arrangements, right? We are worried about whether it is BA or AB, right? So that's the difference which we have to keep in mind in various questions, and we have to see it on case to case basis, right? Now here we are selecting 2 people out of 5 and we are writing it as 5C2. Now imagine that now we have selected 2, and for each 2 we can arrange them in 2 factorial ways, right? Or let's do it later. Let's take few more examples and then see. So as I said that the basic principle of multiplication would give you arrangements. So let's take this example using that basic principle of multiplication. In how many ways can 5 students be arranged in 5 benches? Now we are worried about the arrangements, right? So the basic principle of multiplication would apply here. First bench can be occupied by 5 in 5 ways, second in 4 ways, third in 3 ways, fourth in 2 ways, and finally the last one in 1 way, which is 5 factorial, and this is equal to 120, right? So this is what we have done here when we have 5 students and 5 benches. Now there can be a question that there are 7 students and we have to arrange them, right? The keyword is arrange them. For example, if the question says there are 7 students and we have to select 5 out of them, then what would we have done? It would have been 7C5, right? Mind you, I am not yet introduced with the concept of P. We would introduce the concept P in this question, right? Which means it would be 7 factorial divided by 2 factorial into 5 factorial, right? Which again becomes 7 into 6 into 5 factorial, which would get cancelled, divided by 2. So this is equal to 21. So there are 21 ways of selecting these people, right? But in how many ways can we arrange them, right? So if you see, there are 5 benches, right? Let me make a table. So there are 5. So these are 5 benches. This is first seat, this is second, this is third, this is fourth, this is fifth. So first seat can be filled in 7 ways, this in 6, this in 5, this in 4, and this in 3, right? So total number of arrangements would be 7 into 6 into 5 into 4 into 3, right? Which is equal to what? Which we can say is equal to 7 factorial divided by 2 factorial, right? Which again is equal to what? Which is equal to 7 factorial divided by 2 factorial into 5 factorial. This whole multiplied by 5 factorial, right? Can we write it like this? We can definitely write it like this, right? Or this can be written as 7c 5, right, multiplied by 5 factorial, right? Or we write it as 7p5, right? Or we can say it is equal to npr. So if we say NCR is for selections, NPR denotes arrangements, right? So NPR is direct consequence of basic principle of multiplication, right? A basic principle of multiplication would give you the value of NPR, right? So NPR is equal to 7 into 6 into 5 into 4 into 3, whatever this value is, that would be the value of NPR. Or NPR is written as, in factorial forms, it would be n factorial divided by n minus r factorial, right? It was 7 factorial by 2 factorial, right? It was n minus r factorial. This is what NPR is, right? So just keep in mind what is NPR and what is NCR and what is the relationship between NPR and NCR, because it would come handy in lots of questions, right? So this is NCR and that was NPR. I hope that by this way you are much more clear than what is NPR and what is NCR and where to use NPR and where to use NCR, right? The difference is just about selections and arrangements, right? Now if you look at our previous thing, this one, we are doing the same thing, right? So it's NC 2C1 and 3C1 because we are bothered about selections only. We are not bothered about arrangements, right? So that's why we did NC1 2C1 into 3C1. Here again the 2 boys and 3, in how many ways can we choose? 2 students, right? Here we are bothered about arrangements, right? So we would do 5p r which is 2, which is equal to 5 factorial divided by 3 factorial, right? So if you write, just expand 5 factorial, it would become 5 into 4 into 3 factorial, 3 factorial, 3 factorial would get cancelled and you are only left with 5 into 4, right? Here we are not bothered about the arrangements, right? We are just bothered about the selections. So we would do NC2, which is equal to n factorial divided by r factorial multiplied by n minus r factorial, right? So you can either write this, or you know that some factorials would get cancelled, right? So for example, if you have 5c2, you can write 5 into 4, which are which is the two terms of this divided by the lower number. So it is 2, it would become 2 into 1, right? So this is the easy way of doing it. I'll take another example so that you can understand it. So if it says 7c4, what you can do it, you know that there would be a 3 factorial. You can write it as 7 into 6 into 5 into 4, this divided by 4 into 3 into 2 into 1, right? So whatever is the value of r, just multiply those number of terms, right? And below you just write r factorial, right? This is the value of NCR. Now if you notice 7c, if we write 7c3, right, it would be equal to 7 into 6 into 5 divided by 3 into 2 into 1, or let's write it in factorial forms. 7c4 is equal to 7 factorial divided by 4 factorial and 3 factorial, right? 7c3 is equal to 7 factorial divided by 3 factorial and 4 factorial. So can you see that 7c4 is equal to 7c3, right? So there is a property which says NCR is equal to NC, what would be it? It would be NC n minus r, right? Right? NC n minus r would be what? It would be n factorial divided by n minus r factorial, right, into n minus n minus r. So minus of minus r would become plus r factorial, right? So this again becomes n factorial divided by r factorial into n minus r factorial, right? So they both are same, right? So what you can also do is, if there is a big term, let's say if there is something like this 7c5, you can also write it as 7c2, and the calculations become very easy. It would be 7 into 6 divided by 2 into 1, right? So it would be 21, right? So this is how you work with factorial. Now I hope that you are clear with the difference between arrangements and selections, right? Let's go to the next question, which says, now how many 6 letters word can be made from the word Sachin so that no alphabet is repeated? Now SACHIN, these are 6 alphabets in this. Now when we are making words, we are bothered about arrangements, which means AB is different from BA, right? So we apply simple principle of multiplication, which says the first space can be occupied in 6 ways, second in 5, third in 4, fifth into 3 into 2 into 1, which is equal to 6 factorial, and 6 factorial is equal to 720, right? So there can be 720 words if we rearrange the alphabets of word Sachin, right? We'll do the questions where the alphabets are repeating in our next lecture. Now there are 10 students in a class. In how many ways 3 ranks can be awarded? I'll give you around 1 minute to do this question. This is what we have done previously, right? So do this question. I think if you have understood the concept, it would not have taken 1 minute. It would have been solved in around 30 seconds, right? So we have to select 3 ranks, which means arrangements do matter. Therefore, we can apply our basic principle of counting. So it would be 10 into 9 into 8, which is equal to 720 ways in which we can award 3 ranks. Or we can do it as 10p8, 10p3, right? So which would be 10 factorial divided by 7 factorial, right? So 10 factorial divided by 7 factorial, which again boils down to 10 into 9 into 8, right? So this is the right answer on this. Again, read this question. I'll read it for you, and then I'll give you around 1 minute to solve this question. In a competition, there are 2 awards, one for boys and one for girls. If 5 boys and 7 girls participate, in how many ways can the awards be awarded, right? I think you can solve it in 30 seconds if you have got the concept right. And anyways, I'll give you a minute to solve this question. So let's see how do we do it. There are 5 boys and 7 girls, right? And there are 2 awards, one for boys and one for girls, right? Now out of these 5 boys, we can select one in 5C1 ways, right? And then we have to select girls for the awards, which can be done in 7C1 ways, which is equal to 5 into 7, which is 35 ways, right? So 35 ways to select the 2 awardees, right? Now if the question was that we have to select 2 people such that 2 topper are 1 boy and 1 girl, right? So the things would have been something different, right? So a girl topper and a boy topper, right? Which means a girl having first rank and boy having second rank is different from B, G, right? So these 2 are different cases, right? So the number of combinations, the number of arrangements would have been different, right? So we would have taken one case as 5 into 7 and another case as 7 into 5. So total would be 35 plus 35, which is 70, right? So that's the difference of arrangements and selection. This is a generic question. In a carom tournament, there are m boys and n girls. Each student play exactly once with each other students. In how many total number of matches can be there, right? So we have to find the total number of matches. The total number of students are m plus n, right? There are m girls and m boys and n girls. How do we do it? So you have to see whether you are now selecting or arranging it, right? Just take a case in point, right? Let me do it for you. So now if we have 2 people AB as who are competing against each other, right? AB and BA are same, right? They are not different, which means we have to select only. This means there are m plus n people, right? We have to select 2 out of it to see how many teams can be there. So m plus nc2 would be the answer in this case, right? Now in the above question, if it is known that the number of matches between girls and boys are 221, then how many students are the participants? So just try and solve it. I think 1 minute would be sufficient for solving this question. Let's do it. So the number of ways in which boys can be selected is m. Now they have to compete against girls, which can be selected in n ways, right? So the total number of matches between a girl and a guy would be m into n, which is equal to 221. 221 is equal to 13 into how much? 13 into 17, right? So m is so both of them are prime number, right? We cannot further divide them, so m has to be either 17 or 13, and similarly n has to be 13 or 17 respectively. So m plus n would be how much? It would be 30. So this was a slightly complicated question, but if you have got the concept right, you would have been able to solve it right very easily. Now let's do the last question in this session, and then we'll log off. We'll do more questions and more concepts in next session. So it says a question paper has 10 true false question. If each student's answer book is different from the other one, how many maximum number of students can be there, right? So this statement seems to be intimidating, that we have to find the maximum number of students, right? But let's look at it and see if the question says how many pattern of answers can be there, right? So maximum number of students can be equal to the maximum number of patterns, right? How many different patterns can be there? Only those many different students can be there, right? So how many different patterns can be there? Let's see. The first question is either true or false, so there are two ways of answering it. For the second question, again there are two ways of answering it. For third, there are again two ways of answering it. For fourth, again two. Similarly, for 10th, it's again 2. So it would be 2 raised to power 10, right? So these are the total number of patterns of the answers, which means we have how many? 1, 0, 2, 4 different types of answers, and this can be the maximum number of students which can be there if none of the student has matching pattern, right? So this again is simply using basic principle of counting, right? Here in this question we could not have used NPR or NCR because we are not selecting or we are not arranging them in pattern. Perhaps we are arranging them in pattern in some way, but the basic principle of multiplication would come handy in this, right? So when I say we are arranging it in pattern, I am saying we are doing it as true to true, false false, true true, true false, something like this, right? But since there are repeating things, we'll do this concept in our next video, right? So I hope that you are clear with basic principle of counting, the definition of factorial, the definition of combination and permutation. Actually in real life we do first combination, right? Firstly we select and then we do permutation, which means only then we arrange, right? So for example, when you are arranging your books on a book rack, right, you pick up two books from the stack and then arrange them, right? So firstly we are choosing them and then arranging, right? So that if you think that way, the questions would become very easy, right? Try to link it to your daily experience and basic how do you count, right? Basically how do you count, and if you are able to actually visualize these, the things would become very simple. Actually it's nothing, it's just multiplication, addition and all that stuff, right? Even factorial is a multiplication, so it's nothing hi-fi. You have to practice and you have to actually see what the question is asking, whether it is arrangement or selection, right? The main crux of the question lies in to identify whether you are arranging it or selecting the things, right? So if you once identify that, the questions would become very easy, right? So let's wind up this session. Thanks for watching this session, and I hope that you have gained some insights on permutations and combination, and here I wish you all the best for your preparations. Thanks for watching this video again.